Hi everyone, welcome to today's quarantine clinic. Today we'll be discussing how to approach a case of bladder dysfunction. Now, traditionally, bladder has always been a tricky topic to understand. So, we will be first discussing the basic neural anatomy of bladder connections. How does the brain control the bladder? And then we will discuss what are the possible pathologies that could affect bladder function. So step one is to understand the bladder itself. Now, the function of the bladder is to store urine, and the urine comes from the two kidneys. And both the kidneys have ureters that will enter into the bladder and empty into the bladder. Now, from the bladder, the urine has to exit out. So right at the exit, there is one sphincter known as the internal urethral sphincter, and at the exit there is another sphincter known as external urethral sphincter. Now, right from here, I can tell you that urethral sphincters, the external urethral sphincter is under voluntary control and the internal urethral sphincter is involuntary. Okay. Now, this is the basic, and in the wall of the bladder, there is a muscle known as detrusor muscle. And this is the basic anatomy. Now, what do each of these parts do? So, there are two basic states in which the bladder could function. One is that the urine will have to exit, so that is known as voiding. And the other state is when the urine will not have to exit, so that is storage. And the entire discussion of bladder function is about how does the brain balance between these two states. So you can imagine if it is like a seesaw, you have voiding on one end and storage on the other. And the brain has to balance between these two. So when we talk of voiding, what we mean is that the urine inside the bladder has to come out. And the way this happens is the detrusor muscle has to contract. So that will increase the pressure. The internal urethral sphincter has to relax and the external urethral sphincter has to relax. So then the urine can come out. And this is voiding. And when we talk of storage, we mean the exact opposite. The detrusor has to relax. Therefore, the pressure will be decreased and the internal and external urethral sphincters both have to constrict. And this will lead to a storage state. So these are two opposite systems and both of them have to work in harmony, because sometimes the urine has to be stored and sometimes the urine has to be voided. And if there is a dysfunction in either one of these, then we call it a bladder dysfunction. So now let us look at each one of these two states a little bit more in detail. What does a state of storage mean and what does a state of voiding mean? So for that, you need to know how each one of these three parts is controlled. So you need to know how the detrusor is controlled, how the internal urethral sphincter and the external urethral sphincter is controlled. So let us look at what happens when the bladder gets full. So initially, a bladder has a baseline capacity of 500 ml. Okay. So assuming that the bladder starts getting filled, and let's say that it gets filled up to half. So it gets filled up to 250 ml. The bladder will send a signal up to the brain, and the brain will send a signal back saying void. And this is known as the micturition reflex. This is the basic micturition reflex. So if there is filling up to 200 or 250 ml, the bladder senses that the bladder walls are getting stretched, and this stretch gets sent up to the brain and the response comes back to void. Okay. Now this stretch is sent up by A delta fibers. This much is simple. We will discuss what happens in the brain later, but first let us just understand what happens in the bladder. So when the urine gets filled up, say around 200 250 ml, the A delta fibers will carry the stretch sensation up to the brain. It will go through the spinal cord, then up to the brain, and then it will come back with a void response. And this void response will then cause the detrusor muscle to contract and the internal and external urethral sphincter to relax. So this is the basic micturition reflex. Now let us look at what happens after the A delta fibers have left the bladder. So the bladder is now filled, maybe 200, 300 ml filled. The A delta fibers have taken the stretch reflex and it has now entered the spinal cord. Okay. So I drew the spinal cord a little too long. Let's say the spinal cord ends here. Okay. Now the spinal cord has four parts. You have cervical, you have thoracic, you have lumbar, and sacral. So these are the four parts of the spinal cord. And these A delta fibers will carry the stretch reflex to the sacral part. And from the sacral part, it will go all the way up to the pons. Now the pons is an area in the brain stem. It is between the midbrain and the medulla. And in the pons, there is something known as pontine micturition center. And this pontine micturition center is what will ultimately send the signal back saying void. Okay. Now, what is special about sacral area? So here you need to revise your knowledge of autonomic nervous system. Now your autonomic nervous system has two parts. One is sympathetic, one is parasympathetic. Okay. And in the spinal cord, the sympathetic nerves will exit from your thoracic to the lumbar. So this is thoraco-lumbar outflow. And your parasympathetic will exit the spinal cord through the brainstem and the sacrum. So that is known as craniosacral outflow. Okay. So this is something that you have to just remember, that parasympathetic fibers will exit through the sacrum and your sympathetic fibers will exit through the thoracic and the lumbar. And for the sake of this discussion, for the bladder discussion, our important areas are lumbar for the sympathetic and sacral for the parasympathetic. So from now on, every time I say sacral, you are thinking parasympathetic, and every time I say lumbar, you are thinking sympathetic. Okay, so now let's get back to our micturition reflex. The A delta fibers have felt the stretch. It has taken the stretch sensation to the sacrum. From the sacrum, it has gone up to the pons into the pontine micturition center. The pontine micturition center has taken the signal back to the sacrum, and from the sacral fibers, the command comes to void. And this command to void comes via pelvic nerve. Okay. And this pelvic nerve carries parasympathetic fibers. Now, we've already discussed that in voiding, what happens? Your detrusor will contract and internal sphincter will relax. So, this is the whole micturition reflex. So, one easy way to remember is that when you have the micturition reflex, your pressure will get transmitted to the pons where you have your pontine micturition center, which will act on your parasympathetic sacral fibers via your pelvic nerve to cause voiding. Okay, so this is your micturition reflex. Now, what does the sympathetic system have to do with this? So the sympathetic system has the opposite role. The sympathetic system is trying to store the urine. So it is a storage state, whereas your parasympathetic is a voiding state. The sympathetic system is a storage state. So what does the sympathetic system do? It will cause the detrusor to relax and it will cause the internal sphincter to contract. So then the detrusor will relax so that more urine gets filled into the bladder and your internal sphincters will constrict so that the urine doesn't come out. And what this does is, now suppose that your bladder is getting filled. So it is getting filled up to 200 ml, then up to 250 ml, then up to 300 ml. At every stretch, your A delta fibers is asking the pontine center, can I give the permission? Can the bladder void? And if the return command is no, then the command will go to the sympathetic system. And the sympathetic system will then give the order to the detrusor and the internal sphincter to not void. And this happens via the so the sympathetic system is through the lumbar area, and from the lumbar area you have the hypogastric nerve. Okay, so let's just revise what we've done so far. The bladder is getting stretched. The A delta fibers carries the information up to the brain. The natural response is to void, but if there is a command saying don't void, so supposing you are in public and you don't want a bladder to void right then, the command will, instead of going to the parasympathetic center, it will now go to the sympathetic system, and the sympathetic system via the hypogastric nerve will tell the detrusor to relax and the internal sphincter to contract. Okay. Now, how does this do it? So the parasympathetic system acts on muscarinic receptors, and your sympathetic system acts on your adrenergic receptors. Okay. So this is via acetylcholine and this is via norepinephrine. So now you can imagine that there must be some muscarinic receptors in the bladder to carry out the parasympathetic commands, and there must be some alpha and beta receptors in the bladder to carry out the sympathetic commands. So where are they? So your parasympathetic, the voiding commands, the parasympathetic commands via the pelvic nerve go to the detrusor and acts on the M3 receptors. Now, when it acts on the M3 receptors, it causes the detrusor to contract and for voiding to start. And in the sympathetic, via the lumbar area, via hypogastric nerve, it will act on the beta 3 receptors in the detrusor, which will cause it to relax, because the beta 3 receptors cause muscles to relax, and it will act on the alpha 1 receptors, which causes it to constrict the internal sphincter. So alpha 1 in the internal sphincter, the sympathetic system, when it acts via the hypogastric nerve, it causes the alpha 1 receptors to cause the internal sphincter to constrict, and therefore it reaches a storage state. Fine. Now let's sort of leave the bladder and go up a little. Now we know that the bladder is connected to the central nervous system, and now we know how. We know that A delta carries a sensation to the spine, and we know that the parasympathetic system carries via the pelvic nerve back, and we also have the sympathetic system via the hypogastric. And this is lumbar area, and this is sacral area. Okay, so this much we know. Now what happens? What happens when the sensation goes up? So via the A delta, the sensation has to go all the way up to the pons. So this is the pontine area. Now in the pons and above, there is an area called as PAG. Now what is PAG? PAG stands for periaqueductal gray. So there is an aqueduct, and right around the aqueduct, there is some gray matter. So that is known as periaqueductal gray. And this sensation actually goes up to the periaqueductal gray. And from the periaqueductal gray, the sensation comes back to the pons, to the PMC, which is pontine micturition center. And from the PMC, it comes back to the sacrum and voiding. Okay. Now, there is also an input from the PAG up to the brain, because it's not just important for the brainstem to know that your bladder is full, even you want to know. So your conscious self, you need to know that your bladder is full. So that sensation ascends up. It will go to the thalamus, it will go to the insula, and it will go to the prefrontal cortex. So prefrontal cortex is where you become aware. And once it reaches up in the nervous system, every signal that goes will have a return signal back. So there is a continuous conversation to and fro. So if the signal is going up, there is also a signal that comes down. Now let's think about what has just happened. Your bladder is now full up to 300 ml. The A delta fibers has taken the signal up to the PAG, and the PAG has said void. But wait, let me just confirm. The PAG asks the PFC, the prefrontal cortex. Now, the PAG doesn't know where we are. The PAG doesn't know whether are we at home or are we in a classroom or are we on the bus. So the PAG asks the PFC for permission. The PFC is aware of context. So your frontal lobe is aware of context. So it is a frontal lobe that decides on social inhibition. So if you are in front of other people, you should not void your bladder. So your PFC tells the PAG to not allow the voiding to happen. And so the command, instead of going to the parasympathetic, will now go to the sympathetic area. And so voiding will not happen. Okay. Now, this is the basic neuroanatomy of bladder. Now let us look at what all can go wrong. So let's draw it again. There is one more step that I have to cover, and that is your voluntary control of urine. Now, everything that I covered so far was involuntary. So there is a stretch and then it goes up, and then the command comes down either to the sympathetic or the parasympathetic. What happens if the urine is now come up till 400 ml and the urge to pass is too much? Then the pressure builds up so much that your internal sphincter opens. And so the urine will come up to the external sphincter. Now, here is where your voluntary control of urine comes in, because your external sphincter is under voluntary control by a nerve called as pudendal nerve. And your pudendal nerve comes from the sacrum, S2 to S4. It arises from a nucleus known as Onuf's nucleus. And Onuf's nucleus is directly under your voluntary control. So even if your bladder is full and your internal sphincter opens, you can stop voiding by shutting down the external sphincter. And this happens via the pudendal nerve. So that is the last step in your bladder discussion. Now coming to sites of the lesion. Now, where all can the lesion be? You can have a lesion in your cortex. You can have a lesion in the subcortex. You can have a lesion in the pons or anywhere below the pons, but above the sacrum. Or you can have a lesion in the nerve fibers connecting the bladder to the spinal cord. Okay. So these are the different kinds of lesions that you can have. So this is known as, there's a cortical lesion. You can have a subcortical lesion. You can have a pontine or an infra pontine suprasacral. So what does this mean? It is below the pons but above the sacrum, or you can have an infrasacral. And by infrasacral, you mean either in the bladder itself or in the nerve fibers connecting the bladder to the spinal cord. So these are the different sites of lesion that can happen, and each one of these sites will affect the bladder in a different way. So what will happen when there is a lesion in each one of these areas? Okay. Now let's take a lesion in the cortex. And at every stage, we will take a clinical scenario. If there is a lesion in the cortex, so your prefrontal cortex is now out of the picture, but everything else below that is intact. So now your bladder is filling up, and it has filled up to 200 ml. Okay, so it is filling up to 200 ml. Now what will happen? Your A delta fibers will take it to the sacrum. It will go up to PAG. The PAG will ask the prefrontal cortex, but there is no response because your prefrontal cortex is now out of the picture. So then the PAG will tell the PMC that you go ahead and you void. And when the command for the voiding comes, the parasympathetic supply will work like it is supposed to. So it will act on the detrusor to contract. And once the detrusor contracts, the internal sphincter will relax. And because your prefrontal cortex is gone, your onus nucleus will not cause your external sphincter to contract, because why should it? So then you will have voiding. So in a cortical lesion, you will have a intact micturition reflex, because your basic micturition reflex is still active. So up from the A delta up to the PAG to the PMC and back via the parasympathetic, this reflex is still intact. So there will be almost complete evacuation. And clinically, what this means is that there will be no post-void residue. So what does post-void residue mean? Suppose your bladder is full and it is now contracting. After passing of urine, if your bladder still has some amount of urine left, so if it has 200 ml of urine still left after passing of urine, then this is known as post-voidal residue. But in a cortical lesion, this will not happen because there will be complete evacuation. Okay. But what will happen is that because your prefrontal cortex is now out of the picture, you won't have voluntary control and you will have no insight. So you won't feel guilty in passing urine in front of other people because you are not aware that this is something that should not be done. Okay, so in cortical lesions, so such as in dementias, you will have complete evacuation, but your insight may be lost. Now, what about subcortical lesion? Now, in a subcortical lesion, the lesion will be, your prefrontal cortex may be intact, but the lesion is in some of the connections. Now, this is a tricky one because your prefrontal cortex is intact. So what are the two things you can say? One is that your micturition reflex is intact. So there is little or no postvoidal residue. That is one. And two, your insight may be preserved. So the person is aware that I shouldn't pass urine here, but he is not able to control it properly because the brainstem is calling the shots by itself because there is something wrong with the connection. Now, moving still further down, what if the lesion is at the pons? Now, the thing with a pontine lesion and an infrapontine lesion is that they both have the same effect. The effect being that now the pons is no longer in contact with your lumbosacral area. Okay, so whether there is a lesion in the pons itself or there is a lesion below the pons, anywhere in the spinal cord, at the cervical or the thoracic level, the outcome, the final outcome is that the pons is now disconnected from the lumbosacral area. So now what will happen? So now in this case, the lumbosacral area is sort of doing its own thing. So now if there is a lesion here, everything else is still the same. Your A delta fibers is taking the stretch reflex to the sacral area, and the sacral area is trying to communicate to the pons, but there is no response. And eventually the sacral area will give the command to void. But unfortunately, your lumbar area is also active because usually it is the pons that controls these two. And so if one is active, the other is stopped. So if the parasympathetic is active, the sympathetic is supposed to step back. But now, because your PMC itself is gone, both your parasympathetic and your sympathetic will start acting independently. And so the sympathetic may also give the command to store. And this is known as detrusor dissynergia. So it is known as detrusor sphincter dissynergia. So it is DSD. So what this means is that your parasympathetic may be telling the detrusor to contract, whereas your sympathetic may be telling the internal sphincter to also contract. So there is pressure coming from above, but there is no relief in the internal sphincter pressure. So this is a painful condition. So in an a pontine lesion or an infrapontine lesion, there can be pain. What else can be there? You can have, now because your internal sphincter is constricted and your urine is continuously coming in from the kidneys, you will have increased bladder volume. So your bladder will go on expanding as more and more and more urine gets collected. Now, eventually the pressure will cross a threshold and then your internal sphincter will get overcome. Because there is so much pressure that your internal sphincter will get overcome. And so some urine will leak out. So there will be leaking of urine. And when some urine gets leaked out, the pressure will decrease and then the internal sphincter will again shut. So there will be incomplete evacuation. Okay. Now in this condition, obviously your micturition reflex is lost. So there will be incomplete evacuation. And on top of that, if you have internal sphincter constriction, then you will only have leaking of urine. And this leaking of urine is known as interrupted flow. Okay. So what are all the things that can happen here? You can have, as soon as the bladder is stretched even a little, you can have your parasympathetic trying to void. So you get urgency. Because your internal sphincter is constricted, you will have hesitancy because you can't void it. You have interrupted flow. You have incomplete evacuation. You can have pain. So these are all the features of a pontine or an infrapontine suprasacral lesion. Now coming to the last part, what if it's an infrasacral lesion? So now your brain is okay, your brainstem is okay, your spinal cord is okay, but there is a lesion somewhere in the nerves. Now here what will happen? So first of all, what can cause this kind of problem? You can have a conus medullaris. Now, if you remember from our discussion of paraparesis, you can have a conus medullaris, you can have a cauda equina, or you can have a peripheral neuropathy. So any one of this can cause an infrasacral lesion. And here what is happening is that your connection of the bladder to the spinal cord itself is lost. And then what will happen is, if your bladder is getting filled, either the efferent is gone, so your spinal cord has no idea that the bladder is getting filled, in which case it might just keep getting filled more and more, or your afferent is gone. So even if the spinal cord knows that it is getting filled, it is unable to send the return signal that you can void now. Either way, there will be highly increased bladder volume. There will be a lot of post-void residue. And how does it void? There will be overflow incontinence. So what does overflow incontinence mean? Now the bladder and the spine are no longer connected. So this is like an independent unit. So whenever the bladder is filled to such an extent that the urine itself causes so much pressure, and the detrusor is not contracting, but the urine itself is causing enough pressure to cause the internal sphincter to open. And so that much urine will come out, and then the internal sphincter will close again, because the natural state of the internal sphincter is to be closed. And then again, the urine will start filling up. So if there is, say, 50 ml of urine output, and then you do an ultrasound, you'll find 400 ml of urine still in the bladder. So that is, I'm giving you an example, but that is a large postvoidal residue and almost zero to poor flow, because your detrusor is not contracting. Whereas in a suprasacral lesion, your detrusor is contracting. So you have decreased flow, you have interrupted flow, but you don't have absent flow. Okay. And another thing is that, supposing in this infrasacral region, if your sensory fibers are affected, then you have no idea that your bladder is getting full. So you feel no pain. And that is another thing. Your A delta fiber only carries stretch. But if your bladder is filled to a very large extent, then there is another pathway that carries pain, and that is your C fibers. So your C fibers carry pain sensation to the spinal cord. And supposing your sensory supply is gone, then you don't feel any pain. So it is painless distension. But suppose it is your outflow, that is your motor part of the reflex arc that is affected, then you are feeling the stretch, you are feeling the pain, but you're unable to void, that is painful distension. So those are the two types of distension that can happen. Okay, so now coming to what are the possible etiologies. So what can be the etiologies in a cortical lesion? So in a cortical lesion, you can have a stroke. In a subcortical lesion, you can have Parkinson's or Huntington's disease. In a pontine lesion, you can have, again, it could be a vascular lesion, it could be myelitis, that is an autoimmune, it could be multiple sclerosis, NMO, or anywhere there could be a mass lesion, so a tumor. It could be a trauma. So traumatic spinal cord injury is a very common cause of bladder dysfunction. And we already discussed infrasacral is conus cauda and peripheral neuropathy. So this is how you approach a case of bladder dysfunction. The history and examine, so there's not much in examination, but in history, the questions that you ask for is urgency, frequency, hesitancy, uh, urge incontinence, interrupted stream, and pain. So urgency and frequency will be there in almost all of the uh, pathologies, because in any any condition where your uh, micturition reflex is acting independently, you will feel urgency, because as soon as the bladder gets full, even up to 200 ml, you will start feeling urgency, unless it is an infrasacral lesion in which you will have a disconnected bladder. So these are the questions that you ask, and we've already covered in what condition you will get which one. And so accordingly, you can localize. And coming to investigations, depending on where you have localized the lesion, you can go for an MRI brain, MRI spine, and a urodynamic study. So that tests for your bladder um, contraction, your bladder motility, and how much. So this is combined with the ultrasound. So that tests for what is the bladder post-voidal residue in the bladder. Now, one important thing that I need to tell you is that just based on bladder history alone, it is very difficult to localize. So while it is important that you know the anatomy, you know how the uh, network functions, it is very, very important to take a very good history and examination to look for localization that is not based on bladder. So if it is a stroke, you will have weakness, you will have some cortical dysfunction, even in subcortical lesions or anywhere in the neuroanatomy, there will be something else. And that is what you need to pick up, because just based on bladder alone, it is very difficult to localize the lesion. But if the bladder is involved, then it gives you a pointer that there is definitely an organic lesion, and that lesion will be somewhere in this pathway. So somewhere along this pathway, there is a lesion, and then you look at other findings to localize it further. Okay, so that completes the discussion for today. If there are any questions, then you can ask me. Okay, bye. Take care.